In this video, we will solve a question on utility function. The question is, a consumer's utility function is given by utility is a function of two goods x1 and x2 which are related by this function, that is 2x1 minus 1 raised power 0.25 times x2 minus 4 raised power 0.75. The consumer has a total budget of $73 and unit price of x1 and x2 are $2 and $1 respectively. We need to find out the value of x1 and x2 when we combine them. That means the sum of the x1 and x2. So since budget is being given, the income of the consumer is being given here. So with the given income or with the given budget, consumer wants to maximize his satisfaction. Okay, that means consumer want to maximize his utility subject to the given budget. Okay, so that means he wants to maximize utility, which is this very function 2x1 minus 1 raised power. In place of 0.25 I have written 1 upon 4. Then we have x2 minus 4 raised power 0.75. In place of this I have written 3 upon 4. The budget of the consumer will be equal to the price of good 1 times units of good 1 plus price of good 2 times units of good 2 should be equal to the income of the consumer. So that is, in place of P1 we have 2, in place of P2 we have 1. So 2x1 plus x2 should be equal to m. The value of m is 73. Now with the given budget, and let's write it here. So let us say this is the budget line. With the given budget, okay, consumer wants to reach to the highest possible indifference curve, and optimal bundle will lie at a point where the slope of the indifference curve is equal to the slope of the budget line. Okay, so tangency condition requires that the marginal rate of substitution should be equal to the ratio of the prices. MRS is nothing but the slope of the indifference curve, and the ratio of the prices shows us the slope of the budget line. Now MRS is simply the ratio of the marginal utility of good 1 and good 2, and marginal utility of good 1 is being calculated by taking the partial of the given utility function with respect to good x1. So taking partial of this utility function with respect to x1, first we apply power function rule. 1 upon 4 becomes coefficient here, so 1 upon 4. Then we have 2x1 minus 1 and exponent is subtracted by 1. That means 1 upon 4 minus 1 will become minus 3 upon 4 times the derivative of 2x1, which is in the brackets. The derivative of 2x1 will be 2. And since we are taking partials with respect to x1, x2 minus 4 raised power 3 upon 4 will remain same. This is the marginal utility of good 1, and by the same logic, marginal utility of good x2 will be equal to this 3 upon 4. In this case, since we are taking the partial with respect to x2, 3 upon 4 becomes coefficient, then this term remains same, and x2 minus 4, the exponent of this term is subtracted by 1, we get minus 1 upon 4 should be equal to the ratio of the prices. This is the price of good 1, this is price of good 2. Okay, solving this for, when we solve these two things, there gets some cancellation. And if you are wondering how do we get this result here, simply we have transposed this term to numerator. It got multiplied with this term, like I have explained it here. We have x2 minus 4 raised power 3 upon 4. Then when we transpose this term, it will get multiplied, but exponent sign will change. Okay, if it is minus 1 upon 4, it becomes plus 1 upon 4. Bases are same, we can add up the exponents. It sums up to x2 minus 4. Okay, so we have x2 minus 4. By the same logic, we transpose this term to denominator. Okay, and it gets equal to 2x1 minus 1. Then we have 1 upon 4 here, 1 upon 4. Transposing this, it will get multiplied and reciprocated, it becomes 4 upon 3. Then we have this 2 here. Okay, so 4 and 4 gets cancelled, and here this 2 and 2 will get cancelled because these are in multiplication here. Okay, so we can, so this 2 is multiplied to each of these terms, so it will get cancelled here. Solving this, what will we get? X2 minus 4 upon 2x1 minus 1 is equal to 3. Okay, doing cross multiplication here, so 3 into 2x1 is 6x1 minus 3 into 1 is 3 is equal to x2 minus 4. Okay, which implies 6x1 Okay, transposing this minus 4, it becomes plus 4. So minus 3 plus 4 is plus 1, which is equal to x2. Okay, now we plug the value of x2 is equal to this stuff into the budget constraint. So when we plug the value of x2 here, what will we get? Where I have written it here. So we have 2x1 then. So we have 2x1 plus, in place of x2 we have this 6x1 plus 1 is equal to 73. So this comes out to be 6x1 plus 2x1 is equal to 8x1 is equal to 72. Why? Because 1 is transposed, it gets subtracted with 73. So x2 rather x1, when we divide both sides by 8, the value of x1 comes out to be 9. We know the value of x1, we plug the value of x1 in this equation to get the value of x2. So x2 will be equal to, x2 will be equal to 6 into the value of x1, which is 9 plus 1. Okay, so this is 9 into 6 is 54 plus 1, which comes out to be 55. Then the value of x1 plus x2 comes out to be 64. I hope I make myself clear in this video. Thank you.